Yes. Okay. All right, ladies and gentlemen, we're going to do a video for the notes for 1.7 and 1.8. So it's rational functions. And so this is how rational functions, if you remember rational functions from last year, this is how they work. It is literally a fraction, has to be a fraction to be a rational function. And it is a fraction that has a top and a bottom. So again, this is the numerator. This is the denominator. We're going to talk about the end behavior of rational functions, and there are three cases for end behavior of rational functions, and you're always looking for the highest power. So literally, I want the highest power of the top and the highest power of the bottom. Give me 1 second to orient my board, which was already is power on the top. We're talking about degrees. So degree on the top and degree on the bottom. Those are what we're talking about. That's all I care about. The first case, case 1, says if the numerator is less than the denominator. So for example, if I say that f of x is equal to 3x squared minus 5x plus 1 and over 4x to the 5th plus x minus 7, the degree on the numerator is 2. And the degree on the denominator is 5. The bottom is bigger. If the bottom is bigger, you know that the horizontal asymptote is y equals 0, which means that the end behavior of this function is y equals 0 also. So again, what does it do at the ends? Case number 2. Case number 2 says if they are equal to each other. So for example, if f of x equals we'll do 6x squared minus 5x plus 7 over 4x squared minus 1. Again, I just care about the numerator and the denominator, the degree. The degree of the numerator is 2. The degree of the denominator is 2. They are the same, which means it is the ratio of the coefficient of the leading coefficient. That's these two. So it would be 6 over 4 or 3/2, which means the horizontal asymptote is y equals 3/2, which means when I write my limit to infinity, this would be 3 over 2, and negative infinity would also be 3 over 2. You're always simplifying your values. And then the third case, what happens if the numerator is bigger than the denominator? i.e., f of x is equal to 5x cubed minus 2x plus 1 over 6x minus 7. Let's do 6x squared minus 7. Again, the degree of the numerator is 3. The degree of the denominator is 2. If the numerator is bigger by 1, there's a slant asymptote. If they're not, there's no slant, but it still does the end behavior. And the idea is that it's going in a specific direction. It's not going to go to a number. It is going to go to infinity or negative infinity. What we're saying here is it's going to be parallel to the leading coefficient graph. So if you think about this one, I have the leading coefficients, right? So I can talk about y equals 5 over 6x. Those are my leading coefficients. But what I really want to talk about is this graph. Graphically, what does this look like? Graphically, it looks like a diagonal line that's going up. That's what I care about. So it would be the limit as x approaches infinity of f of x, and as x goes to the right, so does y. So that would be positive infinity. And the limit as x goes to negative infinity of f of x, as x goes to the right, the thing's going down, so it's going to negative infinity. So notice that this says minus plus over and plus minus. This says minus plus. It's one of the two. The question is it going to positive infinity or negative infinity? You'll notice that they both do not go in the same direction. They won't. They will go in opposite directions. The question is which way do they go? So that's what you need to figure out too. Here's another example. We're going to call this g of x. So g of x equals, we'll go with 2x squared minus 5x plus 1 over 3 minus x. Now, this is not written in the correct order in terms of degrees, so I'm going to rewrite this. That's the first thing I'm going to do. So I'm going to rewrite this. The top is fine. 2x squared minus 5x plus 1. The bottom I'm going to rewrite as negative x plus 3. The degree of the numerator is 2. The degree of the denominator, negative 1. Oh, sorry, it's not negative 1. The degree of the denominator is 1. So the idea is, again, the numerator is bigger by 1. So you think that the horizontal, the slant asymptote, right, sorry, there's going to be a slant asymptote, and it's going to be parallel, your slant asymptote is going to be parallel to y equals 2 over negative 1. X. It's going to be parallel to that. That's not the equation of the slant asymptote. We're going to talk about that on another date, but it's talking about the parallel. It's parallel to. The reason I want that is that this graph at slant asymptote is going to look like this. It's going down, which means limit as x approaches infinity. All right, we'll do. What did I start with up here? I started with negative as infinity. As x approaches infinity of g of x. So as x goes to the right, this graph is going down because that's where it's going to negative infinity. Because that's where the slant asymptote is going. And the limit as x approaches negative infinity of g of x. As we go to the left, this graph is going up, so it's going to positive infinity. So again, and here I'll write this so you can definitely tell that this is a negative infinity. This is the case where the negative infinity is on the left-hand side versus the right-hand side. All right. So now let's talk about, page. Determine if I have horizontal or vertical or slant asymptotes. So in order to determine if you have a horizontal, vertical, or slant, we're going to talk about the degree. But again, degree of the numerator here is 0. There's no x's. Degree of the denominator down here, that's going to be 2 because there's 2 x's. Bottom is bigger. The horizontal asymptote is y equals 0. For b, the degree of the numerator is going to be 2. The degree of the denominator is going to be 1. The degree of the numerator is bigger. There's no horizontal. There's a slant. Again, we're going to talk about how to find them, but not today. We're just defining that there is one. This one is the degree of the numerator for C is 1. The degree of the denominator is 2. The bottom is bigger. Horizontal is y equals 0. This one, the degree of the numerator is 2. The degree of the denominator is 2. It is therefore the ratio of the coefficients. So y equals 2 over 1 is 2. And now we're going to write limit statements. So the idea of where things are located, again, limit left, limit right. Now I'm going to change these names. I don't want y because I need to define it by a function. So we're going to do f, g, h, and j. That way I can just name them instead of having to write out the whole thing. So again, the degrees. Degree of numerator, 1. Degree of the denominator, 1. They're the same. That means that my horizontal asymptote is going to be the ratio of the coefficients. 1 over 1 is 1. Which means limit as x approaches negative infinity of f of x is 1. The limit as x approaches positive infinity of f of x is also 1. I want you to pause the video. I want you to do the next story, and then I want you to check yourself. Okay, get ready. I'm actually going to skip down. I'm going to do B last, and we're going to talk about that in a second. This is the degree of the numerator for C is 1. The degree of the denominator for C is 2, which means this horizontal asymptote is y equals 0 because the bottom is bigger. Which means whether you're going to negative infinity of h of x or positive infinity, negative, or positive infinity of h of x, they're still both going to be 0. For this one, the degree of the numerator is 2. The degree of the denominator is also 2. So it is the ratio of the coefficients. So that is -2 over 1. That's -2. So horizontal axis of y equals -2. -2. So limit as x approaches negative infinity, j of x is -2. Limit as x approaches positive infinity of j of x is -2. Now I just only skipped b for a second because b has slant. You'll notice the degree of the numerator is 2, the degree of the denominator is 1. It's bigger by 1, there's a slant. So let's talk about the slant parallel line. Parallel slant. Parallel slant asymptote by equals 1 over 1x. So that has a positive slope. That's what I really care about is the positive slope. The limit as x approaches negative infinity, g of x. This graph is going up, so this graph is going up. Limit as x approaches positive infinity of g of x. Oops, I did that wrong. Sorry, to the left, this graph is going down, so this is negative infinity. To the right, this graph is going up, so that's positive. I apologize for that. So again, follow your asymptote. That's where that dotted line is. This one, you'll notice, ladies and gentlemen, that there is a horizontal asymptote. This graph has a horizontal asymptote right here. There's a horizontal asymptote f by equals 2, which means in behavior tells me where it's going. The left says the limit as x approaches negative infinity of g of x is going to 2. As x goes to the left, my graph goes to the left. And it's going to 2. It's holding steady. As x goes to the right, my graph is holding steady at what number? It's holding steady at 2. In behaviors, horizontal asymptotes. That's what we're talking about. Now, we're going to talk about 1.8. 1.8 is talking about zeros and how to find 0. Here's what you need to get the number. Again, it's a rational function. You have a 0 when the numerator equals 0, when g of x equals 0. The numerator equals 0. You are undefined when the denominator equals 0. So the denominator equals 0, you're undefined. Numerator equals 0, you're at 0. We are going to solve these. You're going to identify both the zeros and the undefined values. Number 1 is really nice. Number 1 is literally cross multiplication because there's just a fraction equaling a fraction. So we're going to cross multiply. The bottom has nothing. There are no x's on the bottom, so there's nothing that's undefined. So I'm literally going to cross multiply. And then I'm going to solve. So you can pause the video and go ahead and solve yourself so that you've got some solving going on. That gives you 4x plus 12. 24x minus 40. I am solving for x, meaning I'm getting x by itself. 12 equals 20x minus 40. So 52 equals 20x. Divided by 20. 52 over 20 equals x, but you should simplify. They're both divisible by 10, so that's 26. Oh wait, they're both divisible again by 2. They're both divisible by 2, not 10. So they're divisible by 4. So my answer is 13 over 5. There are no extraneous solutions. Extraneous solutions means x equals where, but it's not valid. That's where you have undefined. So we're going to talk about those for number 2. For number 2, you have to have a common denominator. There is no, this is over 1, so you had to get a common denominator. Which means I'm multiplying this by x minus 1 over x minus 1. So I'm going to have x times x minus 1 over x minus 1 plus 2x over x minus 1 equals 3 minus x over x minus 1. Once you have a common denominator, meaning all the denominators are exactly the same, I'm going to ignore the denominator. You're going to drop it because I really want the numerator to equal I'm going to drop the denominator. Now, what I did not do, and I'm going to go back and do it, is where is it not valid? And it's always not valid where the graph is undefined. Where is it undefined? Where the denominator equals 0. That would be x minus 1 equals 0. So x cannot equal 1. If x equals 1, we have an issue, because that means that I plugged in 1, and I can't because of that bot. So, let's solve. I have x squared minus x plus 2x equals 3 minus x. I'm going to get everything to one side. X squared minus x plus x. Plus x. Plus x. Here, let's do it this way. Unless you're like, you know what did you do? So I'll just do it this way. Minus x plus 2x minus 3 plus x equals 0. Moved everything to the combining like terms. So I have x squared, and I have plus 2x minus 3 equals 0. And you got a factor. Factor. X plus 3 and x minus 1. Those are the factors of -3 that have to be 0. So I get x equals -3, 1. Those are my two solutions. But here's the deal, ladies and gentlemen. If we look back up here, we said that x could not equal 1, which means that 1 is not a solution. This only has -3. 1 is what's considered an extraneous solution. All my math was right, but the original assumption that you could use was the issue. That's an extraneous solution. All right, let's try another one of these. Hold on, I'm missing a page. I am missing a page. Yes, Joe lost a page. One. Okay, hold on. You all start number 3. Gero lost the 3. Yes, there we go. I lost it with the 3. Alright, here we go. X over x minus 3 minus 7 minus 5. 21. X minus 3. Too much colors. First thing I'm going to do for number 3 is I am going to factor. Not changing this didn't change. But I am going to factor the right-hand one because I need to know what the two parentheses are. So if I factored -15, the factors of -15 that add to be 2. So they are -5 and +3, but the problem is they're also +5 and -3. That's the one that I want. So I need it to be +2. Oh, look, that's nice because those are the factors. So where is it undefined? X cannot equal -5 or +3. Keep that in mind when we talk about extraneous solutions. All right. So over here, I'm going to multiply this by x plus 5 or x plus 5. And over here, I'm going to multiply this by x minus 3 over x minus 3. Common denominators. So I have x times x plus 5 over x minus x plus 5 x minus 3 minus 7 times x minus 3 over x plus 5 times x minus 3 equals 24 over x plus 5 times x minus 3. And ladies and gentlemen, notice that all my denominators are the same. Once you have your denominators the same, I'm literally just going to deal with my numerators. If your denominators are the same, your numerators have to be the same. So I'm just going to deal with my numerator. So I literally just wrote my numerator. Because now I can distribute, simplify, and solve. Distribute x squared plus 5x minus 7x. This is a plus 21 equals 24. I have x squared minus 2x, and then I'm going to move the 24 to the other side. Minus 3 equals 0. I'm gonna factor again. X of x is a -3 and +1, so x equals 3 and -1. There's my solution, but the thing that I always have to go back up is this is why you wrote off the side. X can't equal -5 or a 3. Wait, I have 3 there, so I have to cross it out. Because again, that's an extraneous solution. 4 is very similar. I will post the notes if you want to see number 4. I'm not going to do it right now. I'm on to do solving inequalities. If I'm solving inequalities, the first thing that you have to make sure is you have a 0 on one side. If you do not have a 0 on one side, you have to get it. Have a 0 on one side. And then you are going to use a sign chart to do these. That's the whole point of these, is so you have to use a sign chart to do these. You're testing against sign charts to figure out if you're positive or negative. So number 1 is really nice because I just got to talk about the zeros. Again, the zeros are coming from the numerator, and the undefineds are coming from the denominator. The numerator, the zeros, are x equals 3. The denominator, the undefineds, are x equals -2. They both have to go on a sign chart. You cannot do it without both of them, top and bottom. It's equal to 0, so we're good there. So I have -2 and I have 3. First thing I'm doing is picking a number less than -2. -3. You plug -3 into the top. -3 minus 3 is -6. That's negative. -3 plus 2 is negative. That means I have a positive. I personally do not care what number you use, and I don't care what the actual number is. I care about the signs, S-I-G-N-S, of the numbers. I'm going to choose 0 between -2 and 3. 0 minus 3 is negative. 0 plus 2 is positive. Negative over a positive is a negative. And then I'm going to choose 5. 5 minus 3 is positive. 5 plus 2 is positive. Positive, positive, positive. Now this said, greater than or equal to, that means I want where it's positive. It means that I want this portion, this portion. That started at -infinity. It ends at -2. Now, -2 was undefined. All undefineds are in parentheses every single time. Doesn't matter what the symbol is. Undefineds are always parentheses. Union 3 is where we're starting. Now 3 was a 0, so it gets a bracket because it was or equal to, and then to infinity. For number 2, the problem with number 2 is it's not starting at 0. It has to have 0 on one side. So the first thing I'm going to do for number 2 is I'm going to move that 9 to the other side. So I'm going to have 5x plus 2 over x plus 5 plus 9 is greater than or equal to 0. Technically, that 9 is 9 over 1. So that 9 needs an x plus 5 on top and an x plus 5 on bottom. So 5x plus 2 over x plus 5 plus 9 times x plus 5 over x plus 5 is greater than or equal to 0. I'm going to write this as one fraction. So I have 5x plus 2 plus 9x plus 45 all over x plus 5 is greater than or equal to 0. I'm going to go into number 4 spot. So just an FYI. I'm going to go into that spot. I made the space. This is going to be 14x plus 47 over x plus 5. It's greater than or equal to 0. All right. So now it's equal to 0. We're good. Now I have to talk about my zeros and my undefined. My undefined is x cannot equal -5. My zeros, 14x plus 47 has to equal 0. So 14x equals -47. So x equals -47 over 14. That's the number that's going on the sign chart. This said there would be pretty numbers, that have to be. -5 is going first. -47 going from 14. A little bit less than 3. Because 14 times, a little bit more than 3. -3 because 14 times 3 is 42. So a little bit more than 3. -3 and 5/14. So we'll do that. Get that. I'm going to choose this one She's like -10. That way I know I'm really far out. -10, that gives you -140 plus 47, that is negative. And -10 plus 5 is negative. So that's positive. Now I'm going to choose -4, because that's obviously between -3 and -5. -4, so that's going to be negative. Oops. That's going to be -4 plus 5 is positive. This is negative. And then I'm going to choose like 0. Positive, positive, that's positive. Again, I wanted where it was greater than 0, so positive portion, but these greater than or equal to. So negative infinity to -5. -5 was my undefined, so I get the parentheses. Union 47 was a 0, it gets a bracket. -47 to infinity. All right, so for number 3. Number 3, you have to do something first. It's still equal to 0, so that's a good thing. But I need it to have parentheses. So we're going to factor. X squared plus 6x plus 8 factors into x plus 4 and x plus 2. Factors of 4 that had to be, factors of 8 that had to be 6. I need to do my zeros and my undefined. Zeros come from the top, so x equals -4 and -2. And my undefined comes from the bottom, that's x equals 2. So I have 3 this time. So I have -4, -2, and 2. And again, I'm picking numbers that are in these intervals. I'm going to go like -5. -5 plus 4 is negative. -5 plus 2 is negative. -5 minus 2 is negative. Negative, negative, negative makes a negative. I'm going to take -3. -3 plus 4 is positive. -3 plus 2 is negative. -3 minus 5 is negative. Positive, negative, negative makes a positive. 0. 0 plus 4 is positive. 0 plus 2 is positive. 0 minus 2 is negative. Positive, positive, negative is negative. And no, 5. 5 plus 4 is positive. 5 plus 2 is positive. 5 minus 2 is positive. So that is positive. And I'm looking for it's less than or equal to 0. So that is this portion and this portion. So when I talk about writing this, negative infinity to -4. -4 is a 0, so it gets a bracket because it's or equal to. Union, -2 is a 0, it gets bracket. And 2 is a undefined, so it gets a parentheses. For the rest of these, they are on Schoology, the completed notes. I'd like you to go for those on there so that I actually I'm going to do one more. Take that back. You're going to do one more with me. I'm going to get to it. FYI, here's number 5. So again, this was a lesson. So my zeros were at 3 and negative and 0. So negative, negative, negative. So I'm negative. And then I was negative, negative, positive. So I'm positive. And then negative, positive, positive. So I'm negative. Now this is less than, so everything gets parentheses. And then your last one that I want to talk about is this one right here. Where do we, the graph. And so I want to talk about this one real quick. And I'm going to undo this so that I can do this. I am less than or equal to, so that means I am below the x-axis. Where are you below the x-axis? I am below the x-axis here, and I am below the x-axis here. It's always good to kind of highlight and underline. Or equal to means I'm keeping that. There's a vertical asymptote right here. That's what you're not crossing. That's at -3. So I'm starting at -3. That vertical asymptote always in parentheses. That's where you're undefined. Those are your undefineds. And then I'm going to -1, and I'm including -1 because I'm more equal to union. And then I start back up at 2. And then I'm going to 3, but 3 gets a parentheses because it's undefined again. Where is it greater than 0? That means I'm above 0. I'm above 0 here. So negative infinity to -3. I'm also above 0 right here. So that is union -1 to 2. And I'm above 0 over here. And that would be from 3 to infinity. Where are you greater than or equal to 1? Here's 1. That's the y value of 1. That would be this piece right here, this piece right here. So that would be from negative infinity to negative 3, and then from 3 to infinity. Read the new graph. Okay, your homework tonight is on worksheet A. So please make sure you complete worksheet A. These notes need to be uploaded to Schoology. Thank you. Oh, no, stop share. And hold please, because I need to stop recording.